So today we want to start with resultants. Resultants force, equilibrium. Equilibrium of a rigid body and equilibrants. So it has to do with resultant force. Force. Let's start from force. Definition of force. Force. This is anything that changes the initial position of an object either at rest or in motion. So what causes motion is nothing but a force. A force causes motion. From Newton's second law of motion, we state that applied force is directly proportional to rate of change of momentum. So let's see the meaning of momentum. Momentum is equal to product of mass of the body times its velocity. That is momentum of the body. So we have final momentum, initial momentum. Final momentum is equal to final velocity multiplied by the mass. While initial momentum is equal to mass times initial velocity. So change in momentum is equal to final momentum minus initial momentum. So it will be mv minus mu. So this one will give us m bracket v minus u. This formula represents change in momentum. So this can now be stated as rate of change of momentum, that is m. Okay, rate. Let's finish it. So therefore, let's say rate of change in momentum. Rate of change in momentum is equals to change in momentum, then everything divided by time. Everything divided by the change in momentum all over time. All over t. That is rate of change in momentum. Stated as F, that proportional to m bracket v minus u all over t. So m9 is equal to, in order to remove sign of proportionality, you have to introduce k, the m bracket v minus u all over t, where k is equal to is a constant and is taken to be 1, because a Newton is a force acting on a unit mass of a body producing a unit acceleration. Producing a unit acceleration. Producing a unit acceleration is a force acting on a unit mass of a body producing a unit acceleration. So K is taken to be 1 here. So if K is equals to 1, and you know acceleration to be m bracket v minus u all over t. No, v minus u all over t. That is acceleration. So I can replace this by writing K is 1. This is m. V minus u over t is a. So F9 is equals to ma. This is how to prove that force is equals to ma. So we've been able to achieve the force to be mass times acceleration. And the unit of force is Newton. That is a capital N, and it is a vector quantity. It is a vector quantity. It's a vector quantity. So example of a force. Example of a force. Examples of a force are weight. Weight is a force. Tension is a force. Reaction is a force. Thrust, upthrust, simply thrust is a force. And friction. These are examples of a force. Example. Let's see one example. A force of magnitude 20 Newton acts on a body of mass 30 kilogram. Calculate the acceleration with which the body moves, or the acceleration of the body after being acted upon by a 20 Newton force. So from F is equals to ma. This one is given to be 20, is equals to 30a. A9 is equals to 20 divided by 30. So it's equals to 2 divided by 3 meter per second squared. So it gives you this acceleration. But a situation, that is example, a situation where we now have two forces now. One is acting here, the other one is not acting. This one is 20 Newton, this one is 30 Newton, and the mass is still remain 30 kilogram. And the question says calculate the acceleration. So we must find a way of combining 30 Newton and 20 Newton together in order to produce a single force. That force will be able to represent the effect produced by a 20 unit force and a 30 Newton force. A 20 Newton force and a 30 Newton force combined together. So that in that case we talk of a resultant. We'll find a way of combining 30 and 20 to produce, then you talk of resultant force. So that is introduction to resultant. So a resultant force will now be resultant force. Let me be using R for it, or F. This is a single force. It's very important. It's a single force because you are combining several forces together in order to produce a single one. So this is a single force whose magnitude, value, size, whose magnitude can be used to represent the effect produced by the magnitudes of several forces acting on a body. This effect could come in form of acceleration. When a body is acting upon by a force, meaning it will give an acceleration to that body. That's an effect. So to represent the effect produced by the magnitude of several forces acting on a body, that is a resultant force. But how do we find resultant force? So it depends on the direction of angle. So let's see the int on resultant force. The int on resultant force and the determination of resultant force. What are the ints? Int number. When two forces are acting on a body along the same direction, when two forces are acting on a body along the same direction, how do we find the resultant? Meaning, that is, when the angle between the two bodies, two parallel, look at it, they are parallel. Two parallel forces. You can see clearly the angle between there is 0 degrees. So instead of saying two forces are acting on a body along the same direction, you will be had the angle between the two forces is 0 degrees. So this is what they are saying. Let me call it F1, F2. To find the resultant force will be F1 plus F2 in the direction of F1 and F2. In the direction of F1 and F2, means the body towards this direction. So anytime two forces are acting on a body along the same direction, meaning the two forces are parallel, that is, the angle between the two forces is 0 degrees. To calculate the resultant, you are going to use algebraic sum. They must be added together. It must be noted that when two forces of the same value throughout, you are just changing the angle. So the two forces will produce the maximum resultant when the angle between the two forces is 0 degrees. So when theta is equal to 0 degrees, the resultant force is said to be maximum. Please take note of that. This is the resultant between two forces said to be maximum when the angle between the two forces is 0 degrees. Example. Example 1. Given a body 20 kilograms like this, force 1, 20. Okay, let me start with F2 of magnitude 4 Newton. They are acting on the body. So the question says, calculate the resultant force. That is number 1. Calculate the resultant force. Let me say A. B. Calculate the acceleration with which the body moves. Calculate the acceleration. So the first thing is to find the resultant. F1 plus F2. So to be 3 plus 4. So to be equal to 7 Newton. So B Anything resultant force is equals to mass times acceleration. So resultant is given to be 7, mass is 20, then times A. A now is equals to 7 divided by 20. This is what we are going to have. That is 0.35. Yes. So give you 0.35 meter per second square. That's the acceleration of the body. Then, if you look at example 2, let's look at example 2. Two forces, two parallel forces are acting on a body of mass 10 kilogram along the same direction, along the same direction. If the forces are 2 Newton and 3 Newton, calculate the work done in moving the work done in moving the body through a distance of 20 meters. We have to calculate the work done. So solution now, remember this is the diagram. We said they are parallel in the same direction. So if this is 2, it's going to be 2 Newton here. This one is given to be 3 Newton. And the mass of the body is given to be 10 kilogram. And you are given the distance to be equal to 20 meters. And we have to calculate work done. Work done is equal to force times distance. Work done is equal to force times distance. So the force must be resultant. So if resultant is equal to F1 plus F2. So it's equal to 2 plus 3. So this one gives you 5 Newton. So for that reason, you say work is equal to force, that's the resultant 5, times distance 20. So the answer will be 100 Newton meter or joules. You know, the unit of work is Newton meter or joule, or joules.